Absolute value inequalities, day 2. Our essential question is how do you solve and graph a greater than absolute value inequality? So that means that we're going to have an inequality with absolute value bars and a greater than or equal to symbol. Okay, we're going to start out with the meaning. Remember that absolute value means the distance away from 0. Okay, so for starters, because the first example here just says the absolute value of x is greater than 2, it really is talking about the distance away from 0, because there's only an x in our absolute value bars, and that x will be replaced with a number. So when there's only one term, like one thing in the absolute value bars, like a plain number or plain x, you can think about it as the distance away from 0. So the distance away from 0 is greater than 2. So to explain what this means, I'm going to draw a number line and put 0 on it. Now think about distance. If you are greater than 2 units away from 0, you're more than 2 units away. So if I go 2 units to the right, I'm at positive 2. If I go 2 units to the left, I'm at negative 2. But since it's greater than 2 units away, I would put an open circle on each of those and go further away from 0. Further away. So what I've created is a graph that has two rays on it. So the ray on the left is x is less than negative 2, and I'm going to put or as my connecting word because greater than, absolute value, inequalities with greater than symbols, they represent unions. So x is less than negative 2 or x is greater than positive 2. That would be my solution graph with two rays and my solution written as a compound inequality connected with the word or. Okay, my next one has x minus 1 is greater than or equal to 4. So the first one was the distance away from 0 is greater than 2. So distance away from 0 is greater than 2. Now on this one, we have the distance away from 1 and it's greater than or equal to 4. Distance away from 1 is greater than or equal to 4. So my number line, I need to start with 1 because that's the number that we're marking our distance away from. Now if I go 4 units to the right, I'm at the number 5. If I go 4 units to the left, remember I would have to have 0. So this would be negative 3. Greater than or equal to means that I would have a solid circle on each of these, and greater than that distance away means further away. So I'm going to have two rays again, moving away from 4. So my inequalities would be x is less than or equal to negative 3, or x is greater than or equal to 5. Okay, one more of these, explaining the meaning. X plus 3 is greater than or equal to 1. I'm going to rewrite as x minus negative 3, because remember that when you're taking the distance between two numbers, that means that you subtract them to find the distance that they are apart. So, for example, the number 4 and the number 7, 7 minus 4 is 3, or even 4 minus 7 is negative 3. Both of those absolute values are 3. So the distance between them is 3. Distance is always positive. That's why we have absolute value bars. So this last one means the distance away from -3 is greater than or equal to 1. So greater than or equal to 1 unit away from -3. So my starting point is -3. If I move 1 away, to the right is -2, to the left is -4. So greater than or equal to 1 away, so I need closed circles. Going further away on my -2 and my -4. So 2 rays again. X is less than or equal to -4, or X is greater than or equal to -2. Okay, so remember when our inequalities, when our absolute value inequalities are kind of basic, like just x, x minus 1, x plus 3, we can think about the meaning as the distance away from a number, and we can draw the graph and write the inequalities, compound inequalities like I just did. When the problems get more difficult, you do want to have a second method to use, and so I'm going to show you that second method, where we keep case 1 positive and we solve. So I'm going to solve the first one in blue. So I add 6 on both sides, and I get x is greater than or equal to 11. Then the second one, remember there are 2 ways to think about the negative sign. On this first one, I'm just going to distribute it. So -x plus 6 then is greater than or equal to 5. I would solve by subtracting 6. -x is greater than or equal to -1, and then dividing by -1, which flips my symbol. So x is less than or equal to 1. So now in this one, I'm going from 1 to 11. I'm going to skip then 1, 3, 5, 7, 9, 11, and just use odd numbers to get this one to fit nicely on our number lines. Remember to line up or stack your number lines, because then it's a lot easier to see how to connect them with the word or. So greater than 11, greater than or equal to, is closed going to the right. Less than or equal to 1 is closed going to the left. Now because my connecting word is or, that means one or the other. So we actually get to keep both of these. We get to keep both of these in our solution. So our solution will have 2 rays going in opposite directions. So we're not looking for where they overlap, which they don't, but we are putting them together because the word or represents a union. So my inequality to go with that solution graph is x is less than or equal to 1, or x is greater than or equal to 11, like that. The next one, I'm going to do the same thing. I'm going to solve both using 2 colors. So this first one, I would have to add 5 and then divide by 2. So x is greater than 4. The second one, I'm going to show you a different option for solving. This negative in front of the parentheses is like a -1. So I could divide away that -1 right away, and that would leave me with 2x minus 5. Dividing by -1 flips the symbol and turns the 3 into a negative. So remember, if you like this shortcut, the original inequality, and then you flip and change. Flip the symbol and change the sign on the 3. You can use that shortcut if you want to. Just make sure that you understand there are 2 changes happening there. Okay, so 2x is less than 2, divide by 2, and x is less than 1. So my graphs need to go from 1 to 4. The first one is greater than 4. Second one, less than 1. I keep both of them because this is a union, and with the union, it just has to be on one or the other. And then I write my inequality, x is less than 1, or x is greater than 4. Make sure that you name both of those rays. Your solution has to have the graph and the inequality. One more of these. Subtract 6 on both sides and divide by 3. X is greater than or equal to 2. Divide by the -1 to get rid of it. So 3x plus 6 is less than or equal to -12. Subtract 6. 3x is less than or equal to -18. And divide by 3. X is less than or equal to -6. Remember, you never want to graph until you've solved both of your inequalities. So we need -6 and +2. So if I go with -6, -5, -4, I think this will fit. Perfect. Okay, so my first graph, greater than or equal to, so closed circle, going to the right. Then my second graph, closed circle, going to the left. And I keep both of them, so that my solution has 2 rays. So when the distance away from something is greater, it's moving farther away. So that's why we would have 2 rays to represent all of these. Because it might be moving in the positive direction away or the negative direction. So x is less than or equal to -6, or x is greater than or equal to 2. You should be able to write a summary now. Make sure that you use complete sentences and answer your essential questions.